What do qubits look like in quantum computing? Imagine peering into the tiny world where the building blocks of future computers are shaped by the strange rules of quantum physics. That's where qubits come into play. And like the classical bits you see in everyday devices, which are either 0 or 1, qubits can be both at the same time. This superpower allows quantum computers to process complex problems much faster. But what do these qubits actually look like? Well, they aren't just simple on-off switches. They are physical systems designed to behave as two-level quantum entities. One common form of qubits is superconducting circuits. These are tiny electrical circuits made from special materials that conduct electricity without resistance when cooled to extremely low temperatures, close to absolute zero. These circuits appear as small chips with intricate wiring and tiny components on a silicon or sapphire base. The different energy states of the circuit representing the qubit's 0 and 1 states. When manipulated with microwave signals, these circuits can perform quantum operations. Another type is trapped ions. These are individual charged atoms suspended in space by electromagnetic fields inside vacuum chambers. Think of them as tiny charged balls floating in a controlled environment. The qubit states here are based on specific energy levels or the spin states of the ions. To control them, scientists use laser beams that precisely target these ions, making them flip between states or entangle with each other. These setups look like small, high-tech laboratories with laser equipment and ion traps rather than a simple chip. Photonic qubits are quite different. They use particles of light called photons to carry quantum information. These look like tiny beams of light traveling through optical fibers or bouncing off beam splitters. The physical setup involves optical components like lenses, mirrors, and detectors. The qubit states are encoded in properties such as the polarization of the photons or the path they take. This setup resembles a mini optical laboratory with delicate equipment designed to manipulate light at a very precise level. Quantum dots are another form. These are nanostructures that confine electrons or holes, acting like tiny artificial atoms. They are built on semiconductor chips and look like minuscule dots or islands on a surface. Electrical signals are used to control their states, making them useful for scalable quantum devices. Spin qubits relying on the intrinsic angular momentum, or spin, of electrons or nuclei. These are controlled with magnetic fields and microwave pulses. They are often embedded in solid materials like silicon or diamond, appearing as tiny regions within a larger chip. In a quantum computer, all these different types of qubits are housed inside what is called a quantum processing unit. This is the core part of the machine where quantum operations happen. Surrounding it are complex control electronics and cooling systems to keep the qubits stable. For example, superconducting qubits need dilution refrigerators to reach temperatures near absolute zero, which is colder than outer space. So, qubits don't have a simple visual like classical bits. They are physical quantum systems that requiring specialized environments and equipment to create, control, and read. Their appearance depends on the technology used but always involves precise control and extreme conditions to keep their quantum states intact. This is what makes quantum computing both fascinating and challenging.